Hi, this is Patrick Henry, the CEO of QuestFusion with the Real Deal What Matters. We're here today with Ritesh Saraf. Ritesh is a co-founder and the CEO of OmniPhy, which is a semiconductor intellectual property or IP company supplier. OmniPhy delivers specialized interface and communications technology to their customers. Their technology provided greater design margin and faster time to market for established and emerging standards, including high-speed serializer, deserializers, these are in our industry called SerDes, and high-performance Ethernet solutions. Ethernet's the technology that basically connects all computers together, and it's now starting to be used in automobiles and other technologies, which we'll talk a little bit about. OmniPhy delivers this IP in an advanced process technology, which is important to a large number of companies. In the semiconductor business, you basically have different processes as you go into higher performance and higher geometries, more circuits on a printed circuit board. So OmniPhy is able to work in these very deep submicron technologies, which is very important to a number of customers. The company services the industrial, automotive, consumer, and networking segments through its broad portfolio of silicon-proven designs. A little bit about Ritesh. He is a seasoned semiconductor executive with 17 years of leadership experience, leading teams to deliver over 10 high-speed SerDes designs into silicon across multiple foundries. These are factories or manufacturing partners that are used in the semiconductor business, and multiple customers. A critical member of the founding team of Prism Circuits and the Vice President of Engineering, he oversaw its phenomenal growth and helped scale it with over 50 employees and millions of designs shipping in volume. Prior to joining OmniPhy as its Chief Executive Officer, he was the Vice President of SerDes Engineering at Moses through its acquisition of Prism Circuits, where he oversaw the organization and implementation of the entire lineup of SerDes designs. Ritesh holds a Bachelor in Electronics and Communications from the Delhi Institute of Technology and has co-authored several technical publications and U.S. patents. So welcome, Ritesh.
Thank you, Patrick, for having me.
Ritesh and I got to know each other because actually when I was running Entropic, OmniPhy was a key supplier for us, and we were actually OmniPhy's first customer.
The very first one.
When they left Moses to start this company. So how did you make the decision to start OmniPhy?
It was an interesting story. So when we got acquired at Moses back in 2009, we were prosecuting the IP business, and I was running that business as part of Moses. In end of 2011, Moses decided to exit that business because they wanted to focus on IC business.
Okay, so actually doing products versus intellectual property for other people's products.
Exactly. So Moses was doing IC as well as IP at that time, and I was managing the IP business.
Okay.
And when the company decided to exit that business, me and my co-founders felt that there's still a lot of value in being in that business.
Yeah.
And we had been in the business at that point already for 6 years. Right? We had been a vendor for Entropic also at that time.
Of course.
And it seemed like a logical step for us to keep doing that business because we had known that business and been successful in it.
Yeah.
And so as Moses shut down its IP business, we came out of Moses and started OmniPhy again to run an IP business company. Okay.
I recall this was driven mainly by our Vice President of Mixed Signal Technology and our Head of Overall Engineering in terms of the relationship with OmniPhy. But one of the things that they really promoted at the time was, and I like this about startups, sometimes there's challenges working with startups because, there's uncertainty, there's a little bit more risk. But you guys were very flexible, and you had a seasoned team, and that was something that was really important. We want to design on a process technology that some of the big guys like a Synopsys or Cadence was unwilling to do those projects for us. So it was really nice being able to work with you guys. So what was the original business idea and the business model over time, and has it changed over time? Was there some kind of a pivot that happened within your company?
Okay. Good question. Yeah. So originally, when we started OmniPhy, our idea was to do an IP business.
Yeah.
In the same domain or similar domain that we had done in the past, which is SerDes IPs. And when I say SerDes IPs, these would be protocols like USB, which are consumer protocols, and protocols for enterprise, which now go into high-end computing or high-end networking in the cloud infrastructure.
Yeah.
So these would be protocols like 10G KR, and more recently 25G KR, towards 100 gig Ethernet.
Okay.
So our thought was that we want to be at the leading edge in terms of bandwidth, in terms of data rate. Right. Because that's something we had been doing in the past, and we wanted to continue that. But as we got started in this business, we had to react to the market conditions. We had to react to how the competitiveness of our products was with relation to what was already there in the market. And we had to react to what the customers were demanding. And where there was a scarcity of solutions. So the first product, or the first set of products which we worked together with Entropic, we're focused on the consumer market. Right, because Entropic was developing a set-top box solution for the consumer market, so our IPs were tailored towards the consumer market. Right, and as we tried to sell those, we experienced a lot of competition because we were trying to compete with the biggest players who had been doing the same things. And in 3 years, 4 years back, mobile and consumer was considered very hot. Right, so there was a lot of competition. And for a smaller company, it took a lot of investment to create a differentiation that we wanted. And so through this process, we had developed certain IPs like Ethernet. Again, we started working with Entropic, and then we went to the market and tried to sell those out. And surprisingly, we saw a whole lot of traction for those technologies because those technologies were not available as IP. And so Ethernet is an interesting story. Ethernet as a protocol is probably 25 years old.
At least,
right? So the first Ethernet PHYs were defined in 1990 with 10 meg transfer rates, and then maybe near 2000 was the gigabit came about, and so forth. But surprisingly, all the installations of Ethernet till a few years ago had been as ICs, not as IPs.
Interesting.
So companies like Broadcom, companies like Marvell, had been selling a lot of Ethernet chips into solutions. It started as enterprise, but later on even as consumer. Right. So today, if you look at TVs, smart TVs, right, they'll have an Ethernet port. Your gateway router at home has an Ethernet port. Your set-top box has an Ethernet port. So a few years back, all those functionalities were supplied by IC companies. And as process nodes started becoming newer, and the integration capacity of those processes became higher, our customers started thinking, why can't I integrate this function? Right? It's the SoC mindset, right? Basically, the whole system becomes a chip. And for the longest time, Ethernet had been outside of this SoC.
Well, so much cost was driven out of the Ethernet PHY that was relatively cheap to buy a discrete solution, and there wasn't 100% attach rate for that technology on all these different, Internet of Things type of products.
Sure, but a lot of the consumer companies still had to have it, even though it may not be always used.
Exactly.
So they had to put it in. And so as this integration increased, the cost of silicon also decreased. Right. So, and at some point there was a crossover. Right. If
there always is.
Even if Ethernet, an Ethernet port was selling for 50 cents or 70 cents, if some company was going to sell 5 million of it, or 4 million of it, even 10 million of it, it didn't justify that level of investment if they could get it for 1/6 or 1/10 of the cost.
Exactly. Isn't that crazy? It's just when you get into the millions and tens of millions and hundreds of millions, pennies and half a penny start to matter on these kinds of solutions.
Yeah. So the interesting thing is that we initially saw a lot of challenge in the consumer market with our other IPs.
Yeah.
But then the popularity of our Ethernet was in the consumer market initially.
Yeah.
Because it is so cost conscious that if somebody's saving 20, 30, 40 cents by doing it, they're willing to invest certain amount of money to get that saving per piece.
Okay. So that's really, and the Ethernet market, as I understand it, is evolving because there's various different flavors. I mean, you've got the traditional, what we used to call 10 base T and 100 base T, and now gigabit Ethernet is what goes into computers and now into TVs and things like that. But you were mentioning off camera a little bit about industrial Ethernet and especially automotive. There's kind of these new flavors of Ethernet. Can you talk a little bit about that?
Sure. Yeah. So Ethernet is having a rebirth of sorts.
Kind of a renaissance. The renaissance of
exactly.
Ethernet.
That its variations and its flavors are being adopted in different applications and different spaces.
Yeah.
And some people may club it as IoT.
Yeah.
Right. It's basically Ethernet is a way of connectivity.
Right.
Right. And wireless is not the solution everywhere.
Exactly.
So the default solution for connectivity becomes Ethernet.
Yeah.
And the reason for that is because it's been there for so long.
Yeah.
It's well understood. There's a whole ecosystem which supplies the Ethernet industry or Ethernet installations.
Yeah. Yeah.
So the cost of installation and maintenance of that installation is also low.
Yeah.
That's why it becomes so attractive to become the connectivity solution.
Okay.
And more specifically to your question, automotive and industrial. So let me talk about industrial first. So in industrial...
And those are typically areas and industries where wireless doesn't work very well because you have a lot of noisiness, either in a factory floor or in an automobile. So having a wire-based solution like Ethernet is very important.
Exactly. Yeah. You got that on the you hit the nail there on the head. So these installations in the factory, production lines, they don't want to have wireless. Yeah. Right, and they want to have predictable, guaranteed connectivity. Yeah. And so Ethernet became the solution there. And there is a plethora of higher level protocols in the industrial Ethernet space. Okay. By higher level, I mean at the controller and application layer. Yeah. But they have all agreed to using the Ethernet 100 base T and 10 base T, 1000 base T and 100 base T as the physical layer connectivity. Yeah.
So the analogy I use is like the Ethernet or these communications protocols are like the freeway system, but you're going to drive different kind of cars on them and different. So all the upper level protocols are how you deliver information, the kinds of information you deliver, but the pavement and the roads and the plumbing is a standards-based solution, which is Ethernet.
Exactly. Yeah. So you said it right. So even in our homes, right? Yeah. We may be watching video, we may be watching, playing a game, we may be reading a book on online. Yeah. We're doing different things, but all that data, all that information is going over the same plumbing. Yeah. So similarly in industrial, it may be doing different things, but it's going over the same plumbing. Yeah. And so in industrial, there is some new features that are required to enhance the Ethernet for the application use in
versus traditional computers.
Versus traditional computers. So few of them, time synchronization, right? So you think of a robot on a production line, right? The robot arm has to move very precisely to do an action, right? Maybe to pick a part from, right? And so there needs to be very precise time synchronization of when that arm needs to go down and pick up a part. Yeah. Right? In the order of milliseconds, nanoseconds. Okay. Right? So now there's some additions to the Ethernet protocol which enable to do that. Okay. And so that's an enhancement to that for industrial. Okay. The other is latency, which is sort of tied to the same thing. That it needs to have a deterministic latency from one end to another. So when a command is given from a server,
and standard Ethernet has historically been pretty bad with predictable latency. So tightening up latency is it's a big challenge.
Yes, so those are challenges that need to be solved, even though you may think that the base technology is the same.
Yeah.
But there's unique challenges in the industrial space
Okay.
that are required to be solved to make it applicable.
Okay.
Right. So now, we've gone through that process. We have established how to do these things.
Yeah.
We're seeing good traction in the market.
Yeah.
And again, a lot of the competition we really see today are not IP providers. The competition we really see are IC providers.
Okay.
So today, there's companies in Japan like Renaissance who've been an industrial supplier. There's companies like Texas Instruments who've been a supplier to the industrial world.
Yeah.
But we have a big advantage compared to them. That as a small, nimble company, we move fast and we adapt to the requirements.
Well, you're doing things that would violate their own DNA as a big company. They're not going to want to license their technology to their competitors, and so you're approaching the market in a completely different way by being somebody that can provide this, somewhat standard, but a lot of differentiation based on all these new things to a variety of different customers that these other big companies are not going to supply this as IP. They're going to want to sell chips.
Exactly. So that is happening. One of the other trends, again, from the industrial space, which is, they had been using commercial off-the-shelf silicon to build all their systems.
Yeah.
Because of so much focus on IoT for industrial,
right?
Especially in Europe, where the German government has put a fund of close to €500 million.
Okay.
Towards industrial automation.
Okay.
And they have christened it as Industry 4.0.
Okay.
Sort of as the fourth industrial revolution.
Okay. Interesting.
Where everything is, everything in the industry is going to be cyber physical, and what that means is, there's no people who are doing job on the shop floor.
Yeah.
Everything is being controlled remotely.
Okay.
And they want to retool a production line in a matter of minutes instead of days.
Okay.
So a lot of efficiency being driven.
Yeah.
And the backbone for all that network capability is Ethernet.
Okay.
So a lot of customers are looking into unique ways to solve those problems.
Yeah.
Right? And there isn't commercial silicon available to solve those problems.
Yeah.
So people are looking at doing their own customized SoC solutions. And that's a really good fit for us when some industrial company wants to do a custom solution for themselves.
Right.
We are right there to enable them with the Ethernet piece of it.
Okay.
And we're creating a huge differentiation for them.
So really, this kind of big, interesting Ethernet opportunity that's the rebirth of Ethernet came out of one of your customers forcing you to do something that you really didn't want to do, but you're going to lose all the other business if you didn't end up doing that.
Yeah. So it's funny, but I guess the learning out of this has been, never avoid looking at a market opportunity.
Yeah.
And keep your eyes and ears open to what your customers want from you.
Yeah.
Really listening to the customer has been a key learning, because that education really tells you what will make you successful.
Yeah. Yeah.
So we talked about industrial, and then automotive is the other space.
Okay.
Right, where Ethernet is making big waves.
Okay.
So traditionally, automotive has had its diverse set of protocols, which are used to communicate between the different engineering control units, or ECUs.
Yeah. So there's multiple subsystems within an automobile.
The car. Yes. And they have to talk to each other. Right. So there's a subsystem for the engine control. There's a subsystem for the powertrain.
Yeah.
There's a subsystem for communication or the debug control or infotainment for the driver. Yeah. Things like that. So traditionally, they have had a lot of different protocols like CAN or LIN, CAN is for Control Area Network. Okay.
So these were basically proprietary protocols that were eventually through alliances or some standards organizations made into standards, or they've always been proprietary?
Some of them are proprietary, like MOST, which is used mostly for multimedia in the car. and the others were more standards. But,
Okay.
kind of, they've grown in a unique way to become standards.
Okay.
And all these connectivity options, they were very low bandwidth.
Yeah.
Right. Most of the connections in the cars a few years back, they had a few hundred kilobits of bandwidth.
Okay. So very slow.
Very slow bandwidth. And
Yeah.
as more infotainment applications were the first ones to drive
Yeah.
bandwidth, but really what has tipped the scales is this automated driving.
Okay.
Right. The goal of the car being fully automated means it has a lot of cameras, it has a lot of sensors.
Okay.
And that means a lot of data has to go back and forth
Yeah.
to enable the car to
Yeah.
function.
Real time. I mean, it's got to
Real
be like this.
And that has necessitated an increase in the bandwidth requirement,
Okay.
which these protocols could not support in the
Sure.
way they were defined.
Yeah.
So that's where Ethernet came in as a solution for the car network.
Okay.
So two goals. One was increase the bandwidth
Yeah.
and provide a path for incremental updates, right? Ethernet as a protocol or as a standard,
Yeah.
like we discussed, been there for 25 years. And they have consistently been able to up the bandwidth.
Yeah.
And,
But they're probably also, at least the automobile manufacturers, automobile electronics manufacturers, probably more specifically, they want to preserve a lot of the good features that they've developed in these historical protocols that maybe sit above the PHY layer. Is that part of what's making Automotive Ethernet different from other flavors? Is incorporation of some of these other kind of bells and whistles or fixtures and faucets that exist currently in cars? Or talk to me a little bit about that.
Okay, sure. So so automotive has its own specific needs.
Yeah.
Like you mentioned.
Yeah.
One of the things is EMC
Yeah.
emissions. So that needs to be incorporated. And that by itself, creates a new design requirement.
Okay.
That's one thing. The second thing is weight. Cabling weight is a big thing in automotive.
Of course. Yeah.
Right.
Yeah.
For every couple of pounds you add on the car, your fuel
The gas
efficiency
mileage,
is
yeah.
going to go down 10 to 15%.
Yeah.
So that became a real constraint on the how you decide
Sure.
the cabling, right? Then the other thing is sleep modes, that you don't consume power. You literally consume zero power when it's not being active,
Yeah.
right? But on the other hand, when it needs to be active, it wakes up as quickly as possible.
Right.
So all these constraints, in some ways are unique to the car
Okay.
for automotive electronics.
Interesting.
And all these are being incorporated
Okay.
into this Automotive Ethernet solution.
Okay.
So EMC is one. Cabling weight, for example, there's a standard Ethernet Cat5 cable,
Yeah.
right?
Yeah.
Which is used.
Yeah.
Everybody's familiar with.
Everybody's familiar
right?
with it. Yeah.
The Automotive Ethernet doesn't use a Cat5 cable.
Interesting.
The Automotive Ethernet uses a single pair unshielded.
Oh wow.
So it's very thin, very lightweight.
Yeah.
So that was a unique solution.
Totally
there.
different requirement.
Totally
Yeah.
different requirement.
Yeah.
So two things accomplished by that. One, the weight was reduced. The second, the cost was also reduced.
Right.
Because the whole solution is targeted towards lower cost as well.
Okay. Interesting.
So these are some of the unique things that kind of went into this process of
Yeah.
defining Automotive Ethernet. And there's a couple of alliances which are working on it,
Yeah.
including IEEE, with active participation from all the car makers,
Yeah.
whether it's European car makers like BMW,
Mhm.
Audi, or the US or the Japanese car
Mhm.
makers, because everybody sees that as the future.
Yeah.
The autonomous car
Mhm.
is the future, and this is a step towards to the autonomous car, because the first step is really to define what is the network of the car.
Yeah. How does it communicate?
How does it communicate?
Yeah.
And this is defining the network.
Okay. Cool. Well, I mean, how big is the market for your types of products? I mean, it seems like it's, with this kind of rebirth of Ethernet, it could be pretty massive.
Pretty massive, especially automotive. So as an example, right? So if you talk about Automotive Ethernet, there is projections that in the next 4 to 5 years, let's say 2020, a standard car would have 18 to 30 ports of Ethernet, right? And there would be about 100 million cars manufactured per year. So it quickly goes into billions of ports.
Billions of ports, exactly.
Again, how fast the market matures and how fast it reaches it.
Yeah. And that's only one segment of what you're going after.
What we are doing. But I would definitely say that that's, from a volume perspective, that's a huge market.
Yeah, it's massive.
The other market, industrial Ethernet, again, that's lesser in terms of volume, but still could be more in terms of number of customers.
Okay.
The third segment in the Ethernet space itself also is the consumer Ethernet.
Okay.
And
you're even seeing opportunities there for you because people are integrating the Ethernet into their system on a chip products where historically the PHY was external.
Exactly. So we have all the biggest TV manufacturers using our solution there.
Wow.
I would be, easy to say. I think we probably supply over 80% of the TVs manufactured.
That's
the
fantastic.
suppliers to make 80% of the TVs. You talk about the biggest ones in Korea.
Yeah.
Both of the LG, Samsung.
Yeah.
Those companies. Then in Japan you have Panasonic.
Yeah.
Then some of the companies in China, and so that's a big market we've supplied our solutions to.
Terrific. So how do you guys make money? Do you charge royalties? Is it an upfront licensing fee? Is it a combination of both? Does it depend on the customers, or how does it work?
It depends on a number of things, and in a lot of cases it's a combination of different things.
Okay.
So certain situations or certain scenarios, more specifically in the consumer world, royalty becomes an overbearing thing for the customer.
Right.
So in that space, it's purely license based.
Okay.
But in the industrial and automotive domain, all of our agreements are royalty based on top of the license fee.
Okay. And that lowers the license fee, and then is there typically like a buyout provision where someone can buy out the royalty, or is pretty much it just kind of continues to go down, but the royalty comes down?
Most of them, the royalty continues, and kind of it scales down with volume. There is certain scenarios where we have even done a buyout. Again, it's
various customer
to customer. What kind of value we see from that.
Okay, cool. So you pretty much have explained how your products work. I know that you've had really good revenue for quite some time, and you've been break even since your first year of operation. So very impressive. You guys have bootstrapped this from the beginning. You've never taken venture money. Yeah. So I'm so proud of you guys.
Thank you. Semiconductors today is a very challenging market to raise venture money in.
It's tough to get venture dollars in the semis for sure.
We did put in our own contribution to get the company off the ground.
I'm sure.
But then, after the first year, we've been cash flow positive.
Great. So what's next for you guys? Are you looking at raising outside money at some point? This sounds like it's a pretty big opportunity. Is that something you guys are thinking about, or you're pretty much going to continue to just kind of organically grow it and kind of take advantage of opportunities that way?
Yes, so our direction right now is to keep doing more of what we are doing.
Okay.
It's been a successful method for us.
Sure.
Going forward, we would get more into more of these strategic areas, like automotive, keep extending ourselves as the experts, going to next generations of there, or in industrial.
Yeah.
And we're in certain cases we are doing some strategic agreements where with the customer or customers, where they might do some level of funding to develop certain things.
Okay.
So work closely together.
Okay.
Enable them with a technology, and they benefit by accessing early access to the market.
Okay.
So overall, we want to focus ourselves on technology.
Yeah.
Right? We want to be the experts in a particular technology. Going and becoming an IC company, that's something people used to think was the best thing to do.
Yeah.
maybe a decade or 15 years ago.
Yeah.
It's gotten more challenging now.
Yeah.
Right? The return on investment that you make is a long time out.
Yeah.
And it's also risky.
Yeah.
So in the model that we have today, we have a quicker return to the investments we make.
Yeah.
Although the multiplier may not be as high till the the royalties kick in.
Right. Right.
But it seems a successful model that has worked for us so far, and we want to take that model itself to the next level.
Okay.
Again, if there's opportunities for us to become part of a bigger company and leverage our technical expertise into something much bigger, that's also an area which we're open to.
Okay. And what's the competitive landscape look like for your products right now? Is it primarily other IC companies, or are there other IP companies now getting into this space?
Yeah. So one of the reasons for the Ethernet product line, specifically the industrial and automotive, us having such a huge success in that, was that there's no competition for us in the IP landscape.
Yeah.
So our competitors are really IC companies.
Yeah.
So we are having a different kind of a discussion when we are competing in those opportunities.
Yeah.
Whereas in the IP space, if there is several providers, then it sort of becomes a race to the bottom.
Yeah.
Where a customer would basically pitch 4 or 5 providers against each other and try to get the best cost out of them.
Right.
So that's something we have tried to consciously not get into.
Okay.
A race to the bottom.
Yeah.
But have ourselves differentiated, bring some unique solution to the market where we're not fighting for price, but we're actually reducing the cost of the customer by giving them solutions which they wouldn't have had.
So even there's a basis of a standards-based technology, which inherently means things will be commoditized. There's enough differentiation, and that differentiation is evolving over time in some of these specialized applications of the base technology. Is that the right way to say it?
Yes, exactly.
Okay.
And I think the key is that to keep up to speed or be ahead of the curve, where you keep being unique.
Right.
Whether it's a new standard or whether it's enhancements or features that create that unique application.
Yeah. Well, is there anything else you'd like to share with our audience of entrepreneurs out there? I mean, you obviously have your battle scars from running a couple companies, and you've been around the entrepreneurial landscape for some period of time. And what are the kind of key words of wisdom you have for our audience around those things?
Sure. So I think a couple of things from my personal learning. First is when you want to become an entrepreneur, I guess people who are already entrepreneurs, you will have ups and downs, right?
Yeah.
So it's like a roller coaster.
Yeah.
And the best thing is to ride it through.
Yeah.
Don't try to jump off. So because you ride it through, something good will come at the end.
Yeah.
The other learning I've had, which we talked about, is listen to the customers. I think from knowing what is required in the market, what will succeed, the key thing is listen to the customer.
Yeah.
A lot of times people who have engineering backgrounds, starting companies, they think they know exactly what's going to work.
Right.
Right? And then you go and build it, and then you go and talk to the customer, and says, oh, I could use something else. I don't really, So I think that's a key learning.
Yeah.
For entrepreneur, for a business to be successful, you got to have your eyes and ears very open.
Yeah.
Listen.
And it's an interactive dialogue, because you've got to. Sometimes they know what they want generally, but it's like I want a cake, but then you give them some kind of cake, and I want different kind of frosting, or I want. So you kind of have to basically get that feedback and have an ongoing dialogue with the customers, because their market landscape is changing and it's a dynamic environment. But so the quicker you can kind of iterate things, it's that kind of whole lean startup concepts. I think you guys have done a great job implementing a lot of those things where you test things and you give customer feedback and you tweak it and you're able to move quickly, which is impressive.
Yeah, and also I think what the learning that has been is there is a path of least resistance for you to move forward.
Yeah.
Right, and that path of least resistance we figured out by talking to people, by listening to the feedback.
Yeah.
Because you might think that I'm so good at this that I'll do the best design that among everybody. But then when you do that, spend time and energy doing that, and then go to the market, that advantage that you built, whether it's 10%, 20%, 30%, may not be what the customer cares about.
Yeah, absolutely.
So even though you build an advantage, it may not be so critical for the customer.
Right.
Because they may be valuing their advantage on certain other parameters.
Yeah. And without that dialogue,
you would be on the wrong side.
Yeah. This is awesome. Well, this has been really fantastic. I know you're a super busy guy. I know you've got this huge operation over in India as well, and you're always out visiting customers, but I'm glad you could take time to talk to us today.
Glad talking to you.
Good to see you. This is Patrick Henry, the CEO of QuestFusion, with the Real Deal What Matters.